So an agent lives for 2 periods. Her utility from consumption in period 1 is C1 and period 2 is C2, and it is given by this. Log C1 plus beta log C2. So U is given by log C1 plus beta log C2. So beta is the usual impatience factor that we have here in this case. Okay. So beta is between 0 and 1. It represents the discount reflecting her time preference. The agent earns W1 in period 1. So income of the agent is W1 in period 1 and earns W2 in period 2. So W2 in period. The rate of interest is R. Agent chooses C1 and C2 so as to maximize utility subject to the budget constraint. This is important. Very different thing has been introduced. Consider a temporary increase in income where W1 increases, but agent does not change her expectation about W2. So imagine this case. Supposedly that your company got some profit this year. And because the company got profit, the company increased the salary of the employee in this period. But that does not mean that your salary of the next period will also be increased. This is just a bonus, one-time bonus that you got. And this we will talk in detail in macroeconomics also. So whenever there is an increase in the salary of any consumer, we always ask the question whether it is a temporary increase or a permanent increase. If it is a temporary increase, we don't change the expectations of the consumer. He will not expect that, his salary will increase in every period. So his expectation about wage in period 2, that is unchanged. That is not changing. It's just that W1, that changed, that increased. So we can say that, my new income of period 1, that is W1 plus maybe I got some bonus. So W1 dash, I got some extra money. That's it. So you have to clarify this thing that the expectation about W2 is not changing, which mathematically means that although DW1 is greater than 0, which means change in wage is happening in period 1, DW2, D means differentiation, derivative, change in wage of period 2, that is 0. This is what this means mathematically. There is a change in the wage in period 1 that has increased is what it is saying. So I've taken it greater than 0. And agent does not change expectation about W2. So DW2 is 0. Now, it says then the marginal propensity to consume of present consumption with respect to W1, which means they've already asked the question, how does consumption in period 1 change when wages in period 1 changes? This is what the question is asking. Now, let us first go ahead and write the budget constraint. So my budget constraint will be W1 plus W2 upon 1 plus R is equal to C1 plus C2 upon 1 plus R. Total income is equal to total consumption. This is my budget constraint. Let us go ahead and form a Lagrange. So in this Lagrange, my aim is to maximize my utility. Utility is given by this. So I will write log C1 plus beta log C2 plus lambda W1 plus W2 upon 1 plus R is minus C1 minus C2 upon 1 plus R. Achha, it's always a good idea to write income on the right hand side, because we always say consumption is equal to income. So always go ahead and take this here. This is always a better way to write the budget equation. Right. Now let's go ahead and let's say what will be del L by del C1. So this will be 1 upon C1 plus lambda minus 1 is equal to 0. So my C1 is coming here and it is coming here. And C1 is getting multiplied with lambda. So this will mean 1 by C1 is equal to lambda. Similarly, del L by del C2 will be beta into 1 by C2 plus lambda into minus 1 by R is equal to 0. So this will mean beta by C2 is equal to lambda upon 1 plus R. This will be equation 1. This will be equation 2. Let us divide equation 1 by 2. So divide 1 by 2 and you will get 1 by C1 upon beta by C2 is equal to lambda upon 1 plus R. So you will get 1 by C1 into C2 upon beta is equal to 1 plus R, and you will get C2 by C1 is equal to 1 plus R into beta. So you will get C2 is equal to 1 plus R into beta into C1. This is your equation. Just put this back in your budget line. So you will get C1 plus, instead of C2, I'm writing this, 1 plus R into beta into C1 upon 1 plus R is equal to W1 plus W2 upon 1 plus R. So you will get C1 1 plus beta is equal to W1 plus W2 upon 1 plus R. So you will get C1 is equal to 1 plus beta W1 plus W2 upon 1 plus R. Achha, one more thing here, just to save time in exam. See, you have to try and you have to link the two things together, what you do in exam. So we have already done the utility functions in detail. Now, if you look at this utility function, let's just see here. My utility function is log C1 plus beta log C2. Do you see that? This is nothing but log C1 plus log C2 to the power beta. This is just log m, n is n log m. So beta goes in the power. And we know that log m plus log n is log m into n. So this is nothing but log C1 into C2 to the power beta. Which means that this part is just a monotonic transformation of my utility function C1 into C2 to the power beta. And we know how to solve Cobb-Douglas function. We know that if I have a Cobb-Douglas function, so C1 star will be alpha, alpha is 1, upon alpha plus beta into m by P1. Prices I have always taken as 1, so prices are 1. So into my income, this will be C1 star. And C2 star will nothing be but beta upon 1 plus beta into my income. So actually, I just have to go ahead. I mean, we have done it through various ways. In the last class, I did it through this method. U dash C2 upon U dash C1 is equal to the ratio of 1 plus R upon 1 plus delta. That's also another way. You can use that also condition. You can use this condition also, where you just see that this is a monotonic transformation of your Cobb-Douglas function. You just find what your, and we know what my total income is of the 2 periods, and I know what my total income is. So I can just, use this formula and get C1 star, C2 star. Alternatively, I can go ahead and I can use this technique of forming the Lagrange. So up to you. All 3 methods are available. And here also, if you see, I got exactly the same thing. So C1, I got alpha upon alpha plus beta into the total income. Income of first period plus income of second period, discounted because I have to bring everything in period 1. This is my answer. So you can, of course, go ahead and use the method of monotonic transformation, use your knowledge of Cobb-Douglas function and get the answer. Now here, let's do a total differentiation. So I will get DC1 is equal to 1 upon 1 plus beta, dW1 plus dW2 upon 1 plus R. Remember that beta and R are the same. There is no change in interest rate. There is no change in my discount factor, in my impatience. Only wages have changed. And the question says that dW1 is greater than 0. But there is no change in expectation of wage 2. So change in wage 2 is 0. So if I put this, I will get DC1 is equal to dW1 upon 1 plus beta. So DC1 upon dW1 will be 1 upon 1 plus beta. This is your answer. Till here, you can get this in one sentence if you use monotonic transformation, or if you refer to the last lecture and you use that condition. I just showed you using Lagrange. And from here, you just had to do a total differentiation. This was your total differentiation. This is what is already given to me. I'm just using that information. And from here, I get this value, DC1 by dW1. So let's just look here. So my answer will be C.